Applications in trigonometry. So we've already spent some time looking at how we can use SOHCAHTOA, so those are our trig ratios, sine, cosine, and tangent, to find missing angles and sides in right triangles. We're still doing those things, except now we're applying it into some real life examples. And instead of being able to know exactly what trig ratios you're going to use, you're going to have to figure out what you're going to use, and sometimes you're going to have to draw your own diagram too. In these examples, we're going to do 3 that look at finding the lengths of a side and finding the lengths of an angle. And so we're always going to start with the same process. Step number 1 will be to always label the sides of your triangle. So across from your right angle will be the hypotenuse. Across from the angle that's given to you is the opposite side, and beside that angle is the adjacent side. Once you've done that, you have to ask yourself, what do I know? I know my hypotenuse side. What am I trying to find? I'm trying to find my opposite side, and the opposite in hypotenuse comes from the sine. So I'm going to do the sine of theta, or the sine of an angle, is equal to the opposite over the hypotenuse. So once you've labeled the sides and figured out what trig ratio you can use from SOHCAHTOA, always start by writing out that generic trig ratio equation. From here, you're going to substitute in the values that you know from your triangle. I know that my angle is 37 degrees, so I'm going to write sine of 37 degrees is equal to the length of my opposite side, which is x, that's what I'm trying to find, over the length of my hypotenuse, which is 11. From here, you're going to figure out what the sine of 37 degrees is, and that gives us a value of 0.6018. So that is equal to x over 11. And now it becomes an algebra question where we have to isolate for our variable x. So I'm going to, right now, x is being divided by 11. I have to do the opposite of division, which is multiplication. So I want to multiply both sides by 11. 11 divided by 11 is 1, so I'm left with just x on the right-hand side. And on the left-hand side, when I take 11 and I multiply it by 0.06018 and I keep my answer to 1 decimal place, I get a value of 6.6. And I have to think about, what am I measuring these side lengths in? And that would be centimeters, so 6.6 centimeters. And every word problem needs a therefore statement or a concluding statement. So therefore, the length of side AB is 6.6 centimeters. So make sure that you show your steps, that you include your units, that you really look to see how many decimal places you need to keep in your final answer, and you include your concluding statement for that question. So we're going to follow the same steps for each of these questions in this lesson. So I'm going to start by labeling my sides. So here's the triangle that's given to me. Across from my right angle is the hypotenuse. Across from my given angle is the opposite side, and beside the angle is my adjacent side. I need to identify what I'm looking for. So I'm looking for my adjacent side. I know my hypotenuse side. And when I think about SOHCAHTOA, I have to ask myself, which one of these trig ratios uses adjacent and hypotenuse? And that's cosine. So I'm writing my generic cosine ratio. So cosine of an angle is equal to the adjacent side over the hypotenuse side. Now I substitute in what I know. So cos of my angle, which is 50 degrees, is equal to x, which is the length of my adjacent side, over 35, which is the length of my hypotenuse side. And now it's very similar to what we did in the example above that, except now I have the cos of 50 degrees. So I'm going to use my calculator to figure out that measurement. Cos of 50 degrees to 4 decimal places is 0.6428, and that's equal to x over 35. I want to isolate for x, so I have to get rid of the 35 on the right-hand side. The opposite of dividing by 35 is multiplying by 35, and I have to do that to both sides of my equation so that they cross out on the left-hand side, because 35 divided by 35 is 1, so I'm left with 1x, or just x. And when I take 35 and I multiply it by 0.6428, I get an answer of 22.5 when I round to 1 decimal place. And I look to see, what am I measuring my side lengths in? I'm measuring them in meters. So now that I've found my answer, I need to write my concluding statement. So therefore, it's asking me to find the horizontal distance between the kite and Jamie. So therefore, the horizontal distance is 22.5 meters. The last example that explores finding side lengths involves example 3. So Jay is supervising the installation of an escalator at a new mall. The escalator will make an angle of 30 degrees with the floor and will rise a vertical distance of 6 meters. What is the horizontal distance of the escalator? That should say escalator, not elevator. To the nearest tenth. So tenth is 1 decimal place. So always begin by labeling the sides of your triangle. So we're going to assume that our vertical distance makes a 90 degrees with the floor. And so across from your right angle is your hypotenuse. Across from the angle that's given to you is the opposite side, and beside your angle is your adjacent side. Ask yourself what you're trying to find. I'm trying to find x, which is that horizontal distance of the escalator. And I know the vertical height of my escalator, which is 6 meters. And so when I think about SOHCAHTOA, I have to ask myself which one of these uses opposite and adjacent, and the answer to that would be tan. So I'm going to start by writing my generic trig ratio. So tan of an angle is equal to the opposite side over the adjacent side. And now I substitute in what I know from my triangle. My angle is 30 degrees. My opposite side is 6. And my adjacent side is my unknown, which is x. At this point, I want to figure out what the tan of 30 degrees is, and that gives me a value of 0.5774 when I keep 4 decimal places. Now, the trick in this question is our x value or unknown values in the denominator of our fraction. And we've gone over this in some of our previous lessons, so we're going to use those same strategies. So what I want to do is I want to get rid of this x in the bottom, and I can do that a couple of different ways. I can either multiply both sides by x, or I could put this over 1 and do cross multiplication. So it doesn't truly matter which method you use. In our previous lessons, we put this over 1 and we did some cross multiplication. In this one, I'm going to show you how you can just multiply what we have in the denominator to get rid of it in the denominator. So you have a different example to look at or a different strategy to use. So in order to get rid of the x in the denominator, I want to multiply both sides by x. So this is a strategy that you can use. So the x's will cancel each other out on that right-hand side. And so what we're left with is x times 0.5774. And that's equal to 6. Now, I also want to get rid of this number that's being multiplied by my x on the left-hand side now. And remember, the opposite of multiplication is division. So I'm going to divide both sides by my 5774, so 0.5774. So they'll cancel each other out on the left-hand side because any number divided by itself is 1, so we're just left with x. And when I take my calculator and work out 6 divided by 0.5774, and I keep it to the nearest tenth, so that's 1 decimal place, I get an answer of 10.4. And I have to think about what am I measuring in. So I'm measuring in meters, and so I have to include that in my final answer as well. And the last thing that you need for word problems is a concluding statement. So therefore, the horizontal distance, because that's what I was looking for, is 10.4 meters. Now let's take a look at some examples where I'm looking for missing angles in my word problems. So example number 4 says a storm caused a 13.5 meter hydro pole to lean over. The top of the pole is now 11.8 meters above the ground, and we want to find the measure of the angle that's formed between the pole and the ground to the nearest degree. So anytime you see the word nearest degree, that means the whole number. So always start by labeling the sides of your triangle. We're going to assume that it creates a straight line or a right angle with our ground. So across from that right angle is our hypotenuse. Across from the angle that we're trying to find is the opposite side, and beside the angle is the adjacent side. Ask yourself what you're trying to find. I'm trying to find this angle. So what do I know? So I know that the opposite side has a measurement, and I know that the hypotenuse side has a measurement. And when I think about SOHCAHTOA, I need to think about which one of these uses the hypotenuse and the opposite, and that's the sine. So write your generic ratio. So sine of an angle is equal to the opposite over the hypotenuse. And now substitute in what you know. My angle is P, so that's what I'm trying to find. My opposite side is 11.8, and my hypotenuse side is 13.5. Take your calculator and work out 11.8 divided by 13.5, and you get an answer of 0.8741. And now this is where we do the opposite of sine. Remember, the opposite of sine is the sine inverse. So that'll get rid of it from the left-hand side. So we're just left with P. And we have to do the sine inverse to 0.8741. Remember, to get to that sine inverse, you might have to press a second function button or a shift button. So you should hopefully know how to use your calculator to figure this part out. And so we get an answer of P is equal to 61 degrees when I round to the nearest degree or the nearest whole number. And every good word problem needs a concluding statement. So therefore, the angle between the pole and the ground is 61 degrees. Let's take a look at another example. Example number 5 says that a tower is supported by a wire. The wire is attached to the tower at a height of 19 meters and to the ground 8.1 meters from the base of the tower. We want to calculate the measure of the angle formed by the wire and the ground, so that would be angle W, to the nearest degree. So remember, nearest degree means the nearest whole number. So always start by labeling your sides. Across from your right angle is the hypotenuse. Across from the angle you're trying to find is the opposite, and beside that angle is the adjacent side. Then ask yourself what you know. I know the length of my opposite side, and I know the length of my adjacent side. And then I think about which one of these trig ratios uses opposite and adjacent, and the answer to that would be tangent. So I'm going to go ahead and write my generic trig ratio. So the tangent of an angle is equal to the opposite side over the adjacent side. From here, I'm substituting in what I know. The angle that I'm trying to find is angle W, so I can either keep the theta symbol or I can substitute in for the W. My opposite side is 19. My adjacent side is 8.1, so I'm just substituting those numbers into that. Then I take my calculator and I work out what 19 divided by 8.1 is. I'm going to go ahead and keep 4 decimal places, so it becomes 2.3, 4, 5, and 7 if I round to the nearest, if I round that. And then I have to figure out, okay, now what do I do? So I have to get rid of this tan on the left-hand side so I can isolate for W. The opposite of tanning a number is the tan inverse of a number. So that'll get rid of it from the left-hand side. So I'll just be left with W, and I have to do the tan inverse of the right-hand side. So W is equal to, and when I use my calculator to figure this out, it gives me an answer of 67 degrees to the nearest whole number. And then I want to write my concluding statement. So therefore, the angle formed by the wire and the ground is 67 degrees. And one last example. Elena is building a wheelchair ramp to a deck that is 90 centimeters high, and she wants the wheelchair ramp to be 500 centimeters long. We want to calculate the measure of the angle formed by the ramp and the wall. So that would be this angle measurement right here. And we want to figure out that to the nearest degree, which you should know by now is to the nearest whole number. So always start by labeling your triangle. Across from your right angle is your hypotenuse. Across from the angle that you're trying to find is the opposite side, and beside the angle is the adjacent. What do you know? Well, you know the hypotenuse is 500 centimeters, and the adjacent is 90 centimeters. And when I think about SOHCAHTOA, I have to ask myself which one of those uses the trig ratios that involve adjacent and hypotenuse, and that would be the cosine. So our generic formula is the cosine of an angle is equal to the adjacent side over the hypotenuse. Substitute in what you know. I don't know anything about my triangle in terms of how it's labeled with letters, so I'm going to keep my theta symbol in this question. My adjacent side measures 90 centimeters. My hypotenuse measures 500 centimeters. I take my calculator to work out 90 over 500, and that gives me an answer of 0.18. From here, I need to get theta all by itself, so I have to get rid of the cosine from the left-hand side. The opposite of cosigning a number is taking that cosine inverse, so that I'll make it disappear from the left-hand side. So I'm just left with theta, and I have to do the cos inverse of the right-hand side, which is the cos inverse of 0.18. And when I do that and I write my answer, I get an answer of 80 degrees, and that's to the nearest degree. And so lastly, my concluding statement is therefore, the angle formed by the ramp and the wall measures 80 degrees. If you have any questions about this lesson, please reach out to me, send me an email, sign up for a virtual help session, and I will see you in the next lesson.